All right, this is section 12.7. We're going to talk about similar solids. If we did section 11.3 this year, this will kind of be piggybacking on that, and if not, you're going to hear everything in this lesson to kind of cover surface area and volume for similar figures. So there are, our description for similar figures is two solids that are the same type, so we can't compare cylinders to pyramids, that won't work. Cylinders to cylinders. They have to have equal ratios. That's going back to our scale factor. So they have to be proportionally the same. So if this one's twice as big, then every measure on here gets times by 2 to go bigger. And you're usually comparing like their heights or their radiuses. You could even say like their side lengths are similar. So these guys are similar. Looks like if I took the shape and maybe multiplied by 2, every piece got bigger. So the radius, which would be right here, got larger. The height, which is right here, got larger. Over here, though, even though my radius seemed to get larger, my height stayed the same. So they are not similar cylinders, okay? Are these solids similar? And the way that you check that is by just checking their scale factor. So I'm going to match up radius with radius, and it does not matter if you do big to small or small to big. You just have to keep the ratio the same. And I decided to go small to big, so that's the way I got to keep going. And the small is the 10 and then 15. I'm just going to put a question mark in the middle because I don't know yet if they are similar. And I'm just going to use my calculator to divide them and see what I get. So 5 divided by 10 and then 10 divided by 15, checking them both out. And they are different. So these are not similar solids. They have to have the same scale factor in order for us to consider them to be similar. So kind of breaking that down, scale factor is what we have done in chapter 6 where we are just comparing one measurement to another. This is a little tough to see, but it says radius 1 and then radius 2. So we're just comparing those two. And I'm just going to say that the scale factor, I'm going to call that A and call that B. So that would be my scale factor, A to B. Ratio of perimeters is actually the exact same thing. If I added up all of the sides and found the perimeter of any given figure, it would be the exact same as the scale factor. So if the scale factor was timesing by 2, then the perimeters would also be twice as big or half as big. So they follow the same rules as scale factor. When you move into ratio of areas, remember that areas has our units when we label it, and then we square it. So what I'm going to do is just square the A and square the B. So whatever my scale factor is, if I square them, then I'm talking about their areas. For volume, remember our units would be cubed, and so I'm going to take A cubed and B cubed. And so I'm going to refer you guys to that table quite often when we're doing problems to decide which one you're doing. Are you doing plain scale factor? Are you doing areas that are squared? Or are you doing volumes that are cubed? First example, it says the cans shown are similar. So we know that they are similar. They have the same scale factor. And their scale factor is 87 to 100. So I'm going to do SF for scale factor. And that is 87 to 100. Clearly I'm going small to big because the smaller number's on top. Find the surface area and volume of the larger can. So this information they gave me, sorry, my lights just cut out. The information they gave me is pertaining to the smaller can. So all of that information goes with the small can, and we are trying to figure out the large can. So let's do surface area first. If that is scale factor and I want to do surface area, then I need to square them. So 87 squared and 100 squared. And I'm going to set up a proportion. So I know the surface area, which is 51.84. And I'm going to put an X down there because we don't know the surface area of the large shape. So I'm going to grab my calculator. I'm going to do 100 squared. I'm going to times that by 51.84. And then I'm going to divide by 87 squared. So still cross multiplying and dividing. I just happen to have squareds on those ones. So it looks like the area, the surface area of my bigger cylinder is 68.49. And that makes a lot of sense because my smaller one was 51. And these are not that far off of each other. 87 to 100 is not that far off, and these guys are not that far off. So if this scale factor was pretty close, and let's say my answer I got was like 684 instead, that should kind of raise a red flag for me, like, wait a minute, those were relatively close. My answers should be relatively close. If your scale factor was maybe 10 to 100, then they could be farther off because 10 and 100 are farther apart. Let me change that to surface area. Let's put an SA there instead. Now they said for us to find the volume as well. So volume is actually your scale factor cubed. So I'm going to take my 87 and my 100 and I'm going to cube them both. Still set number proportion. Still going to use the volume they give me, which is 28.27. and let's put a V down there for volume. So I'm going to do the same kind of cross multiplying. I'm going to do 100 cubed this time. If you don't remember how to do a cubed, we have this little caret button somewhere in your calculator, and then you can do a 3, so that will do it for you. Times by 28.27, and then we're going to divide by 87 cubed. So it looks like my volume is about 42.93. Oh, I didn't label these. Sorry. These are inches. Inches squared, inches cubed. Which makes sense because 87 again and 100 are pretty close. So my 28 and 42 are also pretty close. They're not wildly different. Okay. Next up, it says the pyramids are similar. It says pyramid P has a volume of 1,000 inches. Inches cubed. And pyramid Q has a volume of 216, so much smaller. Find the scale factor of pyramid P to pyramid Q. So they said P to Q. So that number over 216. And this is not my scale factor. This would be my ratio of volumes. So I'm like starting already with this information, and I'm trying to work my way back to scale factor. So ratio of volumes is actually supposed to be something cubed. So the easiest way to figure that out is just to cube root 1,000, and we're going to cube root 216. So the cubed root on my calculator, I have, it's under a math menu. I have to hit 3 first, and then I have to hit the math menu, and then this is my option. So it turns it into a cubed root. Hold on, I'm going to grab another calculator so you can see it on this kind of calculator. So right here you have a little X and then a root sign, so you can put any root you want where that X is. So I'm going to hit a 3 first, and then second in that button, and it's telling you it's going to put the 3 right where that X is. So I'm going to do 1,000, and looks like that's 10. And I'm going to do the exact same thing. I'm going to find the cubed root of 216, and looks like that's 6. So 10 cubed would have been the 1,000, 6 cubed would have been the 216, which means my scale factor is 10 to 6, and we want to reduce that a little bit, so we'll divide by 2. So my scale factor is 5 to 3. So I can take information no matter where it is in the table, and I can move forward and backward depending on what I need to find. So if you get scale factor and need to work with areas, you just have to square them. If you want to work with volumes, you cube them. And if you happen to get volume, the way that you can work backwards is just by cube rooting. So figuring out what cubed would equal, in our example, the 1,000 and the 216.